Welcome, everyone, to another episode of Saltwater Stories. Today, we are heading back to one of my favorite places on Earth, under the water, that is, the coral reef.
Absolutely. Such a vibrant, bustling underwater city. So much life packed in there.
It really is. Incredible color, incredible energy, but, it's also a pretty tough neighborhood down there.
Oh, definitely. Everything is either trying to hide or trying to hunt. Or maybe both. Survival is the name of the game.
And the creature we're focusing on today, it's a master of that game, an ancient master, actually. Been around for a very, very long time.
That's right. And it's got some serious tricks up its shell.
Seriously, imagine this. An animal that looks like it's wearing a coat made of rainbows.
Okay.
And it has eyes that can see, secret codes in light that we can't even perceive.
And the punch. You have to enter the punch.
Oh, the punch. It packs a wall up so fast, so strong, people say it can actually break glass.
It's true. It's one of those tiny animals that just completely defies expectations with its power.
Okay, so before we properly introduce this superstar, we have this great little story. It really sets the scene for just how intense this creature is. This happened back in 2001.
Right. At the Monterey Bay Aquarium.
Yeah.
A world-class facility. Huge exhibits.
Exactly. And they had this big, beautiful coral reef tank. But the staff started noticing something odd.
Yeah, things were going missing. Specifically, hard-shelled critters. Snails, crabs, even some pretty tough barnacles.
Just gone, vanishing overnight, all pulverized sometimes.
Pulverized is the right word. For nearly a year, this mystery went on. They couldn't figure out what was causing it. It was like an invisible reef bandit was having a nightly feast.
So weird, because whatever it was tiny and really good at hiding.
Until they finally found it.
Yep.
The culprit was this small predator, likely just a hitchhiker. It had probably come in accidentally on a piece of live rock they added to the tank.
A stowaway. And it found itself in paradise, basically, an all-you-can-eat buffet.
Pretty much.
Yeah.
And it was systematically taking out anything crunchy that came near its little hideout.
The aquarium staff, they actually gave it a nickname, didn't they?
They did. They called it Sparky. And the story of Sparky became kind of legendary in aquarium circles.
Because it perfectly showed off the raw power packed into this small animal.
Yeah.
Breaking through shells like that.
Exactly. And it's why now, many modern aquariums actually use extra thick acrylic for their tanks, especially ones with live rock, just in case another Sparky shows up and decides to test the boundaries.
Amazing. Which brings us finally to the champion we're talking about today. The tiny, ancient, superpowered master of the reef.
The mantis shrimp.
The mantis shrimp, yes. It seems like it just collected every cool superpower the ocean had to offer.
It really does feel that way sometimes.
So our mission today, everyone, is to explore the 3 big reasons why this rainbow warrior, as some call it, is just so incredibly tough. We'll look at who it really is, its unbelievable weapon, and its, frankly, mind-bending eyesight.
Sounds like a plan. There's a lot to unpack.
Okay, first things first. Identity. We call it a mantis shrimp. But that name is a bit tricky, isn't it?
It really is. It's kind of misleading right off the bat because biologically speaking, it's not actually a shrimp.
Not a shrimp, okay. Or a crab. Or a lobster.
Nope. Not technically any of those, even though, yes, they're all crustaceans. They all have that hard outer shell. Yeah.
Right. So if it's not in those groups, where does it fit?
It's actually in its own very exclusive scientific club. The order is called Stomatopoda. And get this, they're the only members of that entire order.
Wow, its own order. So it's like completely unique branch on the crustacean family tree.
Exactly. Think of it like finding out your favorite superhero isn't just, a human with powers, but actually a member of a totally separate ancient alien lineage.
Yeah.
That uniqueness is why it could evolve such specialized abilities over millions of years, things no other crustacean can do.
Okay, that makes sense. But the mantis part of the name, that one's more straightforward, right? Based on how it looks.
Yes, that part fits perfectly. It comes from its front pair of claws. They're called raptorial appendages. Big word, but basically they're its weapons.
The ones it uses for punching or spearing?
Those are the ones. And when a mantis shrimp isn't using them, it folds them up really neatly under its head. And they look almost exactly like the folded front legs of a praying mantis, the insect.
Ah, okay, I can picture that. Hence mantis shrimp.
Precisely. And his whole look, the eyes on stalks, the folded arms, the colors, it's earned it another great nickname too.
Which is?
The shrimp from Mars.
That's perfect. It does look a bit alien. Captures that weirdness and the otherworldly abilities.
It really does. And speaking of otherworldly, that nickname also hints at just how incredibly old these creatures are. They are true ancient survivors.
How ancient are we talking?
Well, their particular family line, Stomatopoda, it branched out from all the other crustaceans. Get ready for this. About 400 million years ago.
400 million. Whoa. Okay, put that in perspective for us.
Right, so 400 million years ago, most complex life was still in the oceans. There weren't really big forests on land yet. And this is more than 150 million years before the first dinosaurs showed up.
Before dinosaurs. So these guys, their ancestors, were swimming around when the continents were still mashed together in Pangaea.
Pretty much, yeah. They've seen it all. And what's really amazing is that their basic body plan, that's stomatopod design, it's been so successful that it's carried them through multiple mass extinction events on Earth.
Including the one that wiped out the dinosaurs.
Including that one. It tells you that their fundamental design, the way they hunt, the way they see, the way they protect themselves, it's just incredibly well adapted for long-term survival in a very competitive place like the ocean.
Okay, so we've established it's not really a shrimp. It's an ancient lineage, kind of alien-looking, a true survivor. And to stick around for 400 million years, especially on a busy reef, you'd need some serious skills, some serious weaponry.
Exactly. And that's where things get even more interesting. Because they didn't just evolve one weapon, they specialized. Yeah, it turns out there isn't just one kind of mantis shrimp fighting style. There are actually over 400 different species known today. And they've basically divided themselves into two main groups, two specialized teams.
Like different schools of martial arts, maybe.
That's a great way to put it. Two distinct strategies for survival. And we call them Team Smasher and Team Spearer.
Smasher and Spearer. Okay, the names seem pretty self-explanatory. Let's start with the Smashers. They're the ones famous for, like, the glass-breaking incidents.
They are indeed. The heavyweight boxers of the Mantis shrimp world. Their main weapon is that front appendage, but it's evolved into this incredibly hard, dense, club-like hammer. It's called the dactyl club.
A dactyl club, okay. And they use it to
smash things. They actively hunt prey that have hard shells for protection. Think crabs, snails, clams, maybe even oysters. They find them and wham! One incredibly fast, powerful blow to shatter that protective shell and get the soft meal inside.
Brutal. Efficient. Is there a particular smasher species that's, like, the poster child?
Oh, definitely. The peacock mantis shrimp. That's the one you often see in photos. It's absolutely stunning.
Yeah, a rainbow warrior one?
That's it. Covered in these electric greens, bright blues, fiery oranges, reds. Just spectacular. And these smashers, they usually live in burrows. They either dig themselves or find in hard coral rubble. Gives them a solid base, a fortress to launch attacks from.
Gotcha. So smashers are about brute force, breaking down defenses. What about Team Spear? How are they different?
Spearers are, they're more like the ninjas, the silent assassins. Their strategy is completely different.
Okay, so no hammer club.
No club. Instead, their raptorial appendages, those front arms, are lined with rows of incredibly sharp needle-like spines, sometimes barbed. It essentially forms a deadly spear or harpoon.
Wow, so they're not smashing shells, they're aiming for
soft targets, things that move fast usually. Small fish, worms, maybe other softer types of shrimp, things they can impale.
And their hunting style reflects that, more stealthy.
Exactly. Ambush predators. A spear will often dig a tunnel in softer stuff, like sand or mud. Then it waits, very patiently, right near the entrance. When something unsuspecting swims or crawls past, zip, the spear shoots out with incredible speed, snags the victim. Often, the prey doesn't even know what hit it.
So cool. Two totally different approaches to the same basic tool. Did one evolve before the other?
That's a great question. And yeah, the fossil record gives us clues. It looks like the spearer design is the older one, the ancestral form, you could say.
So spearing came first.
Seems that way. The super specialized smashing club that appears much later in the fossil record, maybe around 126 million years ago, give or take.
And is there a reason for that timing?
Well, scientists think it might coincide with when potential prey, like certain snails and crabs, started evolving tougher, thicker shells. It's like an evolutionary arms race. Prey gets better armor, predator evolves a better weapon to break it. Nature's constant back and forth.
That makes perfect sense. Adapting the tools for the job. All right, let's get to the punch itself. Or the spear strike, for that matter. Because whether they smash or spear, the defining thing is the speed. This is where the numbers just get, well, frankly, unbelievable.
They really do. The smasher's punch, in particular, is often cited as one of the fastest repeatable movements made by any animal on the planet. It happens faster than you can blink, way faster.
How fast are we talking, like miles per hour?
Yeah, the club itself, the dactyl club, It travels through the water at speeds over 50 miles per hour. That's about 23 meters per second, which is already fast for something moving through water.
50 miles an hour underwater. Okay, that's impressive. But I hear the acceleration is the truly crazy part.
That's where it just goes off the charts.
Mm.
Acceleration is how quickly it reaches that top speed. And the Mantis Shrimps Club accelerates at over 10,000 times the force of gravity. 10,000 Gs.
10,000 Gs. What does that even mean compared to, like, a person?
Well, think about a trained fighter pilot or an astronaut during launch. They might experience maybe 5 Gs, maybe 9 Gs for a very short burst. This little shrimp is hitting 10,000 Gs every time it throws a punch. It's accelerating faster than the .22 caliber bullet leaving the barrel of a gun.
That's insane, faster than a bullet. And all that force delivered onto a tiny
It's
point.
about 1,500 newtons of force, yeah, concentrated, which is why it can shatter shells so easily.
There was the analogy I read, if a human could move their arm even like a tenth as fast, they could throw a baseball into orbit.
Something like that, yeah.
Yeah.
It highlights just how completely beyond normal muscle capability this is. No muscle by itself can contract that quickly. It's physically impossible.
So how do they do it if it's not just muscle power?
They use a really ingenious bit of biological engineering. It's called power amplification. Basically, they store up energy slowly and then release it all at once, instantly.
Power amplification.
Yeah.
Okay. Like, how?
Think of it like drawing back the string on a powerful crossbow, or maybe winding up a really strong rubber band. You use your muscles slowly, steadily, to store potential energy in the bow or the rubber band.
Right, building up tension.
Exactly. The mantis shrimp uses its muscles to slowly bend a specific saddle-shaped part of its exoskeleton. This structure acts like a natural spring. Bending it stores up a huge amount of elastic energy.
So the muscles are loading the spring, not firing the weapon directly.
Precisely. And all that stored energy is held in place by a tiny little biological latch mechanism. A trigger.
A latch, like on a mousetrap.
Kinda, yeah. A very sophisticated, fast-acting one. When the shrimp decides it's time to strike, it releases that latch. And bang! All the stored elastic energy in that bent saddle is unleashed instantly, propelling the club forward at those incredible speeds we talked about. Muscle power alone could never achieve that instantaneous burst.
Wow. Okay, so that explains the speed and the force of the physical hit. But I read there's another weapon involved. A secret second hit.
Ah, yes. This is where the physics gets even weirder and, frankly, cooler. The club moves so fast, it literally pushes the water out of the way faster than the water can flow back in.
Okay. What happens then?
It causes the pressure in the water right around the club to drop drastically, so low that the water actually boils. But without the heat, it rips apart, forming tiny, near-empty bubbles of water vapor. This process is called cavitation.
Cavitation bubbles, like the ones that can damage boat propellers.
Exactly the same principle, but weaponized. These bubbles form in the wake of the punch, but they're incredibly unstable. They exist for only microseconds before they collapse.
And when they collapse.
They collapse violently, inwardly. This implosion creates a powerful shockwave that radiates out through the water, and that shockwave acts like a second punch hitting the target.
A shockwave punch, so even if the club itself misses slightly.
The shockwave can still hit, and the collapse of these bubbles is incredible. It generates a distinct popping sound, a tiny flash of light called sonoluminescence.
Sonoluminescence. Light from sound.
Sort of, yeah. Light from the intense energy of the bubble collapse. And it also creates a localized burst of heat that can reach over 4,000 degrees Celsius.
4,000! That's almost as hot as the surface of the sun. For a split second, underwater.
For a split second, in that tiny spot, yes. It's unbelievable. So that shockwave, the heat, the pressure, it's often enough to stun, damage, or even kill the prey, even if the physical Hackle Club didn't land a direct hit. It's a double whammy.
Mind blown. Okay, one more physics question then. If this club is hitting with bullet-like force and creating sun surface temperatures, how does the shrimp's own club not just shatter? They punch thousands of times, right?
Right. They use these things constantly between molds. And the answer is in the club's material structure. It's another masterpiece of natural design. Scientists were fascinated by this too.
So what did they find?
Well, the very outer surface, the part that makes contact, is super hard. It's made of a ceramic-like mineral called hydroxyapatite. Very tough, very resistant to impact damage on the surface.
Okay, hard outside. But that doesn't explain how it absorbs the shock, right?
Right, correct. The real magic is inside the club. Beneath that hard layer, it's made of fibers, sort of like fiberglass, but arranged in a very special way. They're layered, and each layer is rotated slightly relative to the one below it. It forms a kind of spiral pattern going inwards, sometimes called a bullion structure.
A spiral structure inside, how does that help?
Imagine a tiny crack starting on that hard outer surface from an impact. As the crack tries to travel deeper into the club, it hits these rotated layers. Instead of going straight through, the crack is forced to twist and turn, following the spiral pattern.
Ah, so it deflects the crack.
Exactly. Each twist dissipates the crack's energy, slows it down, and prevents it from spreading right through the material and causing a catastrophic failure. It acts like built-in shock absorbers and crack stoppers, woven right into the fabric of the club. It lets them punch again and again without breaking their weapon. Just brilliant engineering.
Okay, so they have maybe the fastest, toughest weapon in the animal kingdom. But a weapon like that is only useful if you can aim it precisely. Which brings us to their eyes. And from what I've read, mantis shrimp eyes might be even more bizarre and amazing than the punch.
That's a tough call, but yeah, their visual system is arguably the most complex we know of. It's truly extraordinary.
Let's start with just how they look. They're on stalks, right?
Yep, eyes on stalks like little periscopes. And the really cool part, each eye can move completely independently of the other.
Independently. So one eye can be looking forward while the other is looking backward.
Or sideways or up or down. Yeah, it gives them potentially a 360-degree view of their surroundings simultaneously. Constant vigilance.
Wow. Okay. But the structure inside the eye is where it gets really wild.
That's right. Think about our eye. It functions basically like one camera, focusing light onto our retina, a mantis shrimp eye. It's like having 3 separate cameras or 3 distinct visual strips packed into each eyeball.
3 in 1.
Each eye is divided into 3 parallel sections, a top part, a bottom part, and this crucial band running right through the middle, horizontally. It's called the midband. Each of these 3 sections views the same point in space, but from a slightly different angle.
Okay, 3 views of the same thing in one eye. What's the advantage of that?
It gives them trinocular vision within a single eye. Now, we humans, we need 2 eyes working together binocular vision to perceive depth and judge distance accurately.
Right, like closing one eye makes it harder to touch your fingers together.
Exactly. But because the mantis shrimp has these 3 overlapping views within one eye, it can judge distance and depth with incredible accuracy using just that single eye. Their targeting system is always locked on, even if the other eye is looking somewhere else entirely.
Trinocular vision. Okay, that's amazing. Now, color. This is where my brain starts to hurt a little. We see color with, 3 types of detectors?
3 types of color-sensitive cells in our retinas, photoreceptors, tuned roughly to red, green, and blue light. Our brain mixes those 3 signals to create all the millions of colors we perceive.
Okay, 3 for us. How many does the mantis shrimp have?
Get ready. They have somewhere between 12 and 16 different types of photoreceptors.
12 to 16 instead of 3.
Yep. A massive increase. And these extra receptors allow them to see wavelengths of light that are completely invisible to us. Most notably, they have multiple channels dedicated to seeing ultraviolet UV light.
UV light. So they're seeing a whole world we can't, like hidden patterns on flowers or other animals?
Exactly that. Things that look plain to us might have vibrant UV markings for them. It could signal mates, rivals, prey camouflage. It's a whole layer of visual information hidden from us. They're literally seeing the world in a different light.
So when scientists first discovered this, like 12 or 16 receptors, did they assume the shrimp must see way more colors than us, like a super rainbow?
That was the logical first thought. Everyone figured, wow, with 12 channels instead of 3, they must perceive millions upon millions more distinct colors. Their world must be unbelievably rich visually. Makes sense, right?
Yeah, totally. But
when they actually tested their color discrimination, the results were surprising. It turns out they're actually not very good at telling the difference between similar shades of color.
wait, what? They have all those receptors, but they can't tell light orange from dark orange easily. Something we do effortlessly.
Strange, isn't it? They struggle with fine color distinctions that are simple for us. So the big question became, why evolve and maintain 12 to 16 separate color channels if you're not using them to see subtle shades? What's the point?
Yeah, what is the point then?
It seems to be about speed over detail. Our brain takes the signals from our 3 color receptors and does a lot of processing. It compares them, interpolates, figures out the precise shade, gives a rich, detailed color image. That takes time. Maybe only milliseconds, but it's processing time.
Okay. And the mantis shrimp doesn't have time for that.
Apparently not. It needs to make split-second decisions. Is that a threat? Is that food? Is that a mate? Can I punch it? It can't afford the processing delay of figuring out the exact perfect shade of blue.
So how do the 12 receptors help with speed?
The thinking now is that each of those 12 to 16 receptors acts more like a simple on-off switch for a very specific narrow band of color. Instead of comparing signals, the shrimp's brain just gets a rapid series of yes or no signals across its spectrum, like scanning a barcode.
Ah, like a barcode. Instantly recognizing a specific pattern of colors without needing to analyze the shades.
Exactly. It allows for near instantaneous recognition of important visual cues. That specific pattern means prey. That flash means rival, allowing it to react with the same incredible speed as its punch. It sacrifices fine color detail for reaction time, a different strategy for seeing.
Wow, okay. But wait, there's still more to their vision, isn't there? Something about polarized light?
Oh yes, the final and perhaps most unique layer of their visual superpowers.
Yeah.
Polarized light.
Polarized light, like in our sunglasses that cut down glare.
Exactly. Normal light waves wiggle in all directions.
Yeah.
Polarized light wiggles primarily in one specific direction or plane. Our sunglasses filter out horizontally polarized light, which is what causes glare reflecting off water or roads.
Okay, can other animals see this?
Some can, yeah. Many insects and some fish can detect linear polarization, that direction of wiggle. It helps them navigate or see through water surface glare. But the mantis shrimp, it goes a step further, a huge step.
What do?
They are the only animals known on the entire planet that can see circularly polarized light.
Circularly polarized. What's that?
Okay, so linear polarization is light wiggling flat in one direction. Circularly polarized light is,
Yeah.
well, it twists as it travels, like a corkscrew, either clockwise or counterclockwise.
The light that twists. Seriously, and they can see that.
They can see it, and they can apparently tell the difference between clockwise and counterclockwise twisting light, which is just astounding. No other animal can do this.
Why? What's the advantage of seeing twisting light?
It appears to be a secret communication channel.
Secret.
Mantis shrimp have certain patches on their bodies, on their shells and appendages, that reflect light specifically as circularly polarized light. They can flash these patches.
So they can send signals using this twisting light.
Exactly. And since virtually no other animal on the reef, no predator, no prey, can see circularly polarized light, these signals are completely invisible to everyone else.
Yeah.
It's like they have their own private, encrypted visual language.
Wow, like sending secret messages in plain sight that only other mantis shrimp can decode. For mating, warnings.
Probably all of the above. Identifying each other, signaling intent during fights, attracting mates, all using a form of light that's effectively a secret code. It's like putting on magic goggles and suddenly seeing hidden, sparkling messages flashing between them. Just incredible.
Okay, so we have this creature with an ancient lineage, insane weaponry, and eyes that see secret codes. You might assume they're just solitary, super aggressive fighters, but their social life is also pretty complex, right? It all revolves around their home.
Very much so. That burrow is absolutely central to their existence. They are definitely homebodies. Once they establish a territory with a good burrow, they tend to stick to it.
And why is the burrow so important? Just protection from predators?
That's a big part of it, yes. But it's absolutely critical during molting.
Molting, when they shed their old shell to grow bigger.
Exactly. And for any crustacean, that's the most vulnerable time. For a short period after they shed, their new shell is soft and offers almost no protection. They're basically squishy.
Like a soft shell crab, but way more weaponized normally.
Right. So during that vulnerable molting period, having a secure burrow to hide in is literally a matter of life and death. So they defend that territory fiercely.
How do they warn off intruders? Just start punching.
They often try to avoid a full-on fight if possible. They have threat displays first. They might spread those raptorial appendages wide, make themselves look bigger. Some species have brightly colored or fluorescent spots they flash as a warning.
Trying to intimidate the rival into backing down?
Exactly. Because think about it. A real fight between two mantis shrimps, especially two smashers, could be incredibly damaging, maybe even lethal for both of them.
Right, even the winner might end up injured and vulnerable.
Precisely. So they've evolved these amazing, highly ritualized fighting behaviors to settle disputes, usually over territory, without causing catastrophic injury.
Ritualized fighting, like they have rules of engagement.
In a way, yes. It's fascinating. If the threat displays don't work, and neither one retreats, they might proceed to a more physical contest. But it's controlled.
How so?
First, there's often more sizing up. They might use visual cues, maybe even a sort of chemical sniff test, flicking their antenna to pick up chemical signals about the opponent's size, health, maybe even how recently they molted.
Trying to gauge if they can win without actually fighting.
Right. But if it comes to blows, here's the key part. They generally don't aim for the head or the soft underside. Instead, they often turn around.
Turn around, so they're facing away from each other.
Well, one might turn its back to the other. And they strike each other almost exclusively on their heavily armored tailplate. It's called the telson.
The telson, so it's like they have a built-in shield on their rear end.
Pretty much. The telson is incredibly tough, designed to withstand these impacts. So they trade blows against each other's tail shields. It becomes a test of endurance and armor integrity.
A kind of shrimp boxing match, but they only hit the punching bag part.
That's a good analogy. And often, the winner isn't necessarily the one who hits the absolute hardest in a single blow. It's the one who shows the most persistence, the most stamina, the one that keeps coming back, proving it has the energy and fortitude to hold that territory.
That's brilliant. So the loser can retreat, usually without fatal injuries, and live to find another territory another day.
Exactly. It's a system that resolves conflict while minimizing the risk of serious harm. Highly sophisticated social behavior for such a seemingly aggressive animal.
And speaking of social behavior, it gets even more surprising, right? They're not all solitary fighters. Some are romantic.
Some species are, yes. While many are solitary, quite a few species are known to be monogamous.
Monogamous, like they pair up for how long?
For a long time. In some species, a pair bond can last for many years, potentially up to 20 years, which might be their entire adult lifespan.
20 years with the same partner? For a crustacean, that's incredible.
It really is. These pairs often share a burrow. Sometimes they even seem to have a division of labor. Maybe the male goes out hunting more, while the female guards the burrow and eventually the eggs.
Ah, so they raise families together in a sense.
They do. The female can lay a lot of eggs, maybe up to 50,000 at once. She often gathers them into a ball and holds them or attaches them inside the burrow. And she is incredibly dedicated to guarding and cleaning them, keeping them oxygenated for weeks or months until they hatch.
Wow. Dedicated parents. What happens when the babies hatch? Are they mini mantis shrimp?
Not at all. They hatch as tiny, transparent larvae, and they look completely alien. Really strange-looking little things.
Larvae, so they don't just start life on the reef floor.
No, they begin life adrift. These tiny larvae spend weeks, sometimes up to 3 months, floating in the open ocean as part of the plankton.
Floating in the plankton, that sounds incredibly dangerous.
It is. They're tiny, vulnerable, food for countless filter feeders and small fish. It's a huge gamble. But if a larva manages to survive that perilous journey, it eventually settles down onto the seabed, finds a tiny crevice to hide in, and undergoes a transformation into a miniature version of the adult, ready to start its life on the reef.
What a journey just to get started. And they have other ways to communicate too, besides the visual stuff. I read something about rumbling.
Yes, another fascinating layer. Besides the light signals and threat displays, some species can actually produce a low-frequency rumbling sound. It's called the stomatopod rumble.
A rumble. How do they make it?
The exact mechanism is still being studied, but they seem to do it inside their burrows. And this low rumble vibrates through the ground, through the sand or rubble.
And other mantis shrimp can feel this vibration.
That seems to be the idea. It likely serves as another territorial signal, like an acoustic keep-out sign that travels through the substrate, warning potential rivals that this burrow, this piece of real estate, is already occupied, using sound and vibration to defend their castle.
Okay, the mantis shrimp is clearly amazing in its own right. But what's also incredible is how we humans are learning from it. This idea of bio-inspiration, right? Looking at nature's solutions to design better things for ourselves.
Exactly. It's become a really hot area of research. Nature has had millions of years of R&D, trial and error, and the mantis shrimp is like a walking, punching, seeing treasure trove of brilliant designs.
So let's talk specifics. That club, the Bulectal Club, how is its structure inspiring new materials?
Well, scientists studied that internal spiral structure, the Bulligan structure we talked about, that stops cracks from spreading. They analyzed exactly how it absorbs and dissipates energy from those high-speed impacts.
And they're trying to copy it.
They are. They're using those principles, the layering, the fiber orientation, to design new composite materials that are both lightweight and incredibly resistant to impact and fracture.
What kind of applications are we talking about?
Things like advanced body armor for soldiers or police officers, potentially much lighter and more effective than current vests. Also, better helmets for military use, for sports, for construction, even potentially components for cars or aircraft that need to withstand high stresses or impacts, copying the shrimp's fist to build better protection.
Amazing. Taking lessons from the reef to protect people. What about the eyes? Those complex eyes must be inspiring something too.
Oh, absolutely. Especially their ability to see polarized light. That's leading to some really exciting potential breakthroughs, particularly in medicine.
Medicine. How can seeing polarized light help with medicine?
Well, researchers realize that different types of biological tissues reflect polarized light differently. Healthy tissue reflects it one way, but sometimes diseased tissue, like cancerous cells, reflects it in a slightly different pattern.
Because the cells are structured differently.
Exactly. The structure is disorganized or different.
Yeah.
So scientists have built special cameras that mimic the way the mantis shrimp eye detects different types of polarized light.
Shrimp vision cameras.
Basically, yeah.
Yeah.
And the hope is that these cameras could be used during checkups or even surgeries. By looking at the patterns of polarized light reflecting off tissue, doctors might be able to spot cancerous or precancerous areas much earlier or more accurately than they can with the naked eye or current imaging.
Wow, that could literally save lives. Early cancer detection inspired by a shrimp's eye.
Potentially, yes. It's still in development, but the principle is very promising.
And is there anything else from the eyes? The multiple channels, maybe?
Yes, even that is inspiring technology. The way the eye processes multiple channels of information simultaneously, all those color and polarization channels in the midband, has given engineers ideas for things like data storage.
Just as storage, like computers.
Kind of. Think about DVDs or Blu-ray discs. They store information that's read by a laser. Researchers are exploring ways to use different properties of light, including polarization, similar to how the shrimp eye distinguishes channels, to encode much more information onto a disc of the same size.
So mantis shrimp vision could lead to discs that hold way more movies or games.
That's the idea. Using light's properties in more complex ways, inspired by the shrimp, to dramatically increase data density. It shows how solutions found in nature can pop up in unexpected technological areas.
It really does seem like this little creature holds keys to so many different fields.
And beyond the tech inspiration, we shouldn't forget their crucial role right there in the ocean. They're important ocean engineers.
How so? As predators.
Yes, as predators, they play a vital role in controlling populations of things like crabs and snails. They help maintain the balance and diversity of the reef ecosystem. If you took them out, other populations might explode and upset the whole system.
Okay, keeping things in check. And they're digging. Does that help too?
Absolutely. All that burrowing activity, which scientists call bioturbation, is really important. When they dig, they turn up the sand and mud. This mixes nutrients around, but more importantly, it brings oxygen down from the water into the sediment layers.
Oxygenating the seafloor.
Exactly. Which is essential for all the tiny organisms, the microbes and worms and other small critters that live buried in the sand. The mantis shrimp, just by digging its home, is helping to keep the whole seafloor environment healthy and oxygenated for everyone else living there. They're tiny but mighty ecosystem engineers.
Wow, what an absolutely incredible creature the mantis shrimp is. It's really staggering to think about everything we've covered. It's not really a shrimp, first off.
Right, an ancient, unique lineage stomatopoda, been doing its own thing for 400 million years.
With a weapon, that punch or spear that's faster than a bullet creates cavitation bubbles hotter than the sun's surface.
And backed up by eyes that see a whole secret world of UV and polarized light, including that twisting circular polarization no one else sees.
Plus, it has that built-in body armor, the club structure, that's now inspiring our own technology. It's just packed with superlatives.
It truly is a marvel of evolution,
Yeah.
a living testament to how specialized and, frankly, weird nature can get when it's solving survival problems.
Now, thankfully, the mantis shrimp itself, most species anyway, are listed as least concern in terms of conservation status. They're doing okay overall.
That's good news, yeah, the resilient critters.
But their home, the coral reef, that's a different story, isn't it?
Unfortunately, yes. Coral reefs worldwide are facing serious threats. Rising ocean temperatures due to climate change cause coral bleaching. Pollution from runoff damages the delicate ecosystem. Destructive fishing practices. The list goes on. The mantis shrimp might be tough, but if its home disappears, it disappears too.
So protecting the reefs is key to protecting these amazing animals and everything else that lives there.
Absolutely. And there are things we can all do. Simple choices matter. Using reef-safe sunscreen when you swim in the ocean, reducing single-use plastics that end up as marine pollution, supporting sustainable seafood choices, or just learning more and telling others about why reefs are important. Every little bit helps us become, sort of, reef heroes.
Be heroes, I like that. Well, thank you so much for walking us through the absolutely wild world of the mantis shrimp today. It's been fascinating.
My pleasure. It's always fun to talk about these incredible animals.
And for all of you listening, thank you for joining us on Saltwater Stories. We hope you enjoyed this exploration.
And maybe, as a final thought to leave you with, consider this. We've talked about this animal armed with arguably the most devastatingly powerful weapon, relative to its size, in the animal kingdom. A weapon capable of incredible destruction.
Right, that bullet punch, the cavitation.
Yet, when faced with conflict with its own kind, its primary strategy isn't mutually assured destruction. It's ritualized combat. It's striking the armored tailplate, respecting rules, testing endurance rather than going for the kill. What does it suggest about nature, about survival, that even one of the most powerfully armed creatures on Earth has evolved sophisticated rule-based systems primarily to settle disputes peacefully amongst themselves?
That's a really powerful point. Even the toughest fighter knows the value of rules and restraint. Something to think about.
Definitely.
Thanks again, everyone. See you next time on Saltwater Stories.